Hello dear students, in this lesson I'm going to talking about arc and chord. A central angle is an angle whose vertex is the center of the circle. وهذا central angle ما بس من لم انجلانه كلا سنتري بازنكان امان هميا بيكو بيانو تريس central anglium circle جا دايما central angle circle ميجركي 360 وات امان هميا بيكو كوبكيتو دايما 360 بۆ دەرەچێت. Each central angle has an opposite unbroken part of circle called arc. واتە ئەڵێ هەموو central angleێک بەرامبەرەکەی پارتێک هەیە کە ئەو پارتە پێ ئەوترێ arc. واتە ئێسێمە لەم central angleە CB-یەکەمان ئەبێ بە arc بۆ ئەم central angle و بامان شێوە BZ-ەکەمان arcێکی ترە و ZO کە arcێکی ترە OH arcە و SD-یەکەشمان arcە و DC-یەکەشمان بامان شێوە. The measure of an arc is equal to the measure of its central angle. واتە مێژەری ئارکەکە هەمان مێژەری central angle هەیە. واتە ئێمە لێرە ئەگەر مێژەری ئەم بەشان بزانین لە central angle-کە و کاتە توانین بزانین CB-یەکەمان مێژەرەکەی چەندێکە و بامان شێوە بۆ ئارکەکانی تریش وایە. Thus, the measure of a circle is 360 and the measure of a semicircle is 180. In this example, we have to find the measure of the arc BC. We have to find this measure. So there are 6 congruent central angle. We have 6 congruent central angle. This is 1, 2, 3, 4, 5, 6. So we can say there are 6 congruent central angle. Therefore, the measure of MBC, the measure of angle MBC equal to 360 divided by 6. So 360, because we have 6 congruent central angle divided by 6 equal to 60. So this the measure of BC equal to the measure of BMC, the central angle, equal to 60 degree. Number 2, you have to find the measure of BD. This is BD. So the measure of BD, we can write the measure of BMD. BMD is equal to 2 times 60 because we have 2 equal parts or 2 central angle. 2 times 60 equal to 120. So the measure of BD equal to 120 degree. After that, you have to find the measure of CHZ. So the measure of CHZ, we can say the measure of CMZ equal to 120 because we have 2 equal parts. And then the measure of CBZ also equal to 120 because we have 2 arcs. Thus, the measure of CHZ equal to 360 minus 120, so equal to 240 degree. After that, we have this example. In this example, you have to find the measure of BC. This is BC. First, when we draw a line from each point on the circle to the center of the circle, we will get 5 congruent central angles. So we can say there are 5 congruent central angles. After that, the measure of MBC equal to 360 divided by 5. 360 divided by 5 equal to 72. So equal to the measure of BC. So the measure of each arc for the circle equal to 72 degree. After that, you have to find the measure of CDH. So this is CDH. The measure of CDH, you can say the measure of CDH equal to the measure of MCD plus MDH. And the measure of MCD is equal to the measure of MBC equal to 72. So, and the measure of MDH, so you can write the measure of MCD equal to 360 divided by 5 equal to 72 degree, and then the measure of MDH equal to 360 divided by 5 equal to 72. Also they are congruent, so the measure of CDH equal to the measure of MCD 72 plus MDH is 72 equal to 144. So the measure of CDH equal to 144 degree. After that, you have to find the measure of CHN. So you can say the measure of CHN equal to the measure of MCD plus the measure of MDH and then plus the measure of MHN. So you can say 72 plus 72 plus 72 equal to 216 degree. After that, we have theorem of arc and chord. Within a circle or congruent circle, congruent central angle intercept congruent chords. واتە ئەگەر دوو سنترال ئەنگڵەکە جوود بوون کانگروێن بوون ئەوە ئارکەکەشیان بە ئەمان شێوە ژێەکانیشیان جوود دەبن واتە کۆردەکانیش بە ئەمان شێوە جوود ئەبن congruent chord have congruent central angle واتە ئەگەر دووژەکە جوود بوون ئەوە central ئەنگڵەکانیش بە ئەمان شێوە congruent ئەبن واتە جوود ئەبن congruent arc have congruent intercept chord ئەڵێ ئەگەر دوو ئارکەکە کانگروێنت بن ئەوە دوو کۆردەکەش بە هەمان شێوە کانگروێنت ئەبن congruent chord have congruent arc ئەگەر دوو کۆردەکە کانگروێنت بن واتە جوود بن ئەوە ئارکەکانیش بە هەمان شێوە کانگروێنتە بن. So in this example we have to prove that the triangle LBD is an equilateral triangle. So the measure of BL, this is arc BL is congruent to or equal to the measure of BD, arc BD. This is given. These two arcs are congruent, LB and BD. So we can say BL line segment is congruent to BL is congruent to BD, line segment BD, by theorem of arc and chord, and then the measure of BL is congruent to the measure of arc LD. This is given. We have double lines for each arc. It means they are congruent, and then we can say LB or BL, the line segment of BL is congruent to the line segment LD by theorem of arc and chord. Therefore the triangle LBD is an equilateral triangle. After that, in this example, we have to prove that LBHD is a square. So first, you can say BD is the diameter of the circle is equal to LH because they are the diameter of the circle. After that, you can say BD is perpendicular to the LH, or BD is perpendicular to the, so you can say BD is perpendicular to LH because the point P is the center of the circle and M is the midpoint of the diameter. So the point P is the midpoint of the diameters. When we match these points, so P is a midpoint of these two diameters, and P is the center of the circle, so we can say BL DH is a square. Because if in a quadrilateral the diagonals are congruent and perpendicular, so this quadrilateral is a square. After that, we have theorem of perpendicular diameter. In a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. وهطلع لهر بازنەیەکدا هەر تیرێک لەسەر کۆردێک ئەستون بێت دەبێتە ئارکی ئەو کۆردە. In a circle, each diameter or radius that bisects a chord is perpendicular to a chord. ئەڵێ لە هەر بازنەیەکدا هەر تیرێک کۆردێک bisect کات واتە لەتی بکات دەبێتە تەوەری ئەو کۆردە واتە perpendicular بۆ ئەو کۆردە. In a circle, the perpendicular bisector of a chord intersect the circle in a diameter. واتەڵێ لە هەر بازنەیەکدا تەوەری هەر ژێک تیرەیەکە لە بازنەکەیە. After that, we can use the theorem of perpendicular diameter for solving this problem. In this problem, you have to find the measure of BD. You have to find this measure. The measure of CE is 2 and the measure of CA is 3. So first, we have to find the measure of AD. This radius. So the measure of AD equal to the measure of AD equal to the measure of AE, because both are radius for the circle, and equal to CA is 3 and CE is 2. When we add these two numbers, we will get the measure of each radius for the circle. So 2 plus 3 equal to 5. So the measure of AD and AE is equal to 5. After that, we can use the right triangle DCA. DCA for finding the measure of CD. So the triangle DCA, we can use the Pythagorean theorem CD square plus AC square equal to AD square. CD square plus AC square equal to the hypotenuse AD square. After that, we can rewrite this equation like that. CD square, because we want to find the measure of CD, equal to AD square minus AC square. After that, CD square equal to AD square is 5 centimeter. This is 5 minus AC. AC is 3 centimeter or 3. Now 5 times 5 is 25 minus 3 times 3 is 9 equal to 16. After that, CD square equal to 16. We have to take the square for both sides. So we can say CD equal to 16 is perfect, square equal to 4. And then this C is a midpoint of BD. So you can say C is a midpoint of BD. Thus, BD equal to 2 times 2 times 4 equal to 8. So the measure of BD equal to 8. After that, in this example, you have to find the measure of CD. So first, you have to find the measure of AB. AB is the radius of the circle. So AB equal to, let this midpoint is N. So AN plus NB. So equal to 2.4 plus 1.7 equal to 4.1. So the measure of AB and the radius is 4.1. And then we have to use the right triangle and the Pythagorean theorem for finding the measure of ND. So we have AB square equal to AD square plus DB square. So AB is 4.1 square equal to AD is 2.4 square plus DB. We don't know the measure of DB. So let DB is after that, the measure of DB square equal to 4.1 square minus 2.4 square. When we find the measure of these two numbers, so dB square or dB equal to 3.32. After that, the measure of CD, N is midpoint of CD, so the measure of CD equal to 2 times the measure of dB, so 2 times 3.32 equal to 6.64. So the measure of CD is 6.64. After that, in this example, the measure of EBF and DAC are congruent. We have to find the measure of EBF. So first, we can say this arc CD is congruent to the arc EF. So it means we can say 45. CD is 45 minus 6x. So 45 minus 6x equal to EF. EF is negative 9x. After that, we can change the place of positive 45 to the right side. So we can say negative 6x is equal to negative 9x minus 45. After that, you have to change the place of negative 9x to the left side. So you have positive 9x minus 6x equal to negative 45. We have to subtract these two like terms. 9 minus 6 is equal to 3x equal to negative 45. To get rid of this 3, you have to divide both sides by 3. So these two terms are cancelled. X equal to 45 divided by 3 is negative 15. After that, the measure of EBH EBH is equal to this arc EF. So you can say the measure of EBF, sorry, equal to this arc EF, and equal to negative 9x. So negative 9 multiplied by x is negative 15, equal to 135 degree.